Okay, so welcome to the PainPoint workshops, problems and challenges to tackle through innovation procurement of climate services based on Earth observation. I will start with the agenda for today. We envision a tour de table, but we just go directly today to the context and objectives of PROTECT and see how we're preparing a PCP on climate services based on Earth observation. In the second point, we will look into the EAFIP methodologies to prepare a procurement and focus on step 1 on the needs assessment and the expected outcome that we would like to have from this workshop. And next, we will have some questions and open discussions for you to participate freely. And at the end, we will see what are the next steps after the workshop. So let's go now to the context and objectives of PROTECT. PROTECT has a mission, and that is to prepare and equip a community of public authorities, buyers, to undertake one or more joint cross-border or coordinated pre-commercial procurement processes in order to steer the development of the next generation of climate services based on Earth observation data. So as a matter of fact, PROTECT is preparing itself as a consortium and bringing up together procurers, public authorities that are buyers, to present a proposal for the upcoming Horizon PCP call. This is the call that you see on the slide, as the Horizon CL6 2024 governance, with the purpose of the customization, pre-operationalization of prototypes and user services in the area of climate change, adaptation, and mitigation. So what we're doing now is, as I say, bringing together public buyers that have similar pressing challenges related to climate change in order to be connected and receive support to formulate concrete, realistic needs based on the application domains, 5 applications domains, in order to have the grounds for the PCP. So here I have a first question for you. I will invite you to pick up your phone and scan the QR code. And we have this question: what is the experience of your organization with Earth observation data and or related services? You can just, I'm going to do it also myself so I can know the time that it requires for you to scan the QR code and come in to the question. So we scan it and we go to, here you have the first question. So you can vote. So we have the first participants. We are aware of Earth observation data services, but we are not using them. Okay, so this is perfect for you because today we will have presentation and information on how you can use Earth observation data and services, what is the potential of that, and of course, how can we come together in order to, in this case, prepare the PCP. Okay, so here comes, you go to the next slide. And just for you to keep in mind what are the objectives and the key actions of PROTECT is to facilitate the definition and the aggregation of the needs and the functional requirements for climate services, explaining, fostering, and supporting and buying with impact approach. And of course, we will prepare this operational ground for one or more joint cross-border coordinated pre-commercial procurement, PCP, processes. So that's what we're trying to do today. We want to look into these common needs and try to formulate them as functional requirements. Why do we want to do that? Because the functional and performance-related requirements are the appropriate means to favor innovation in public procurement, and they should be used as widely as possible. This is something that is already in the public procurement directives. And how do you formulate functional requirements? You describe the requirements in a way that an innovative solution must meet, but you leave space to suppliers to come up with new ideas. Perhaps you could also have ideas that you have not even imagined beforehand. So formulating these requirements in a functional manner help us to achieve innovation. There's no innovation without a functional specification. And that's our aim for today. We'll try to see what functionalities you require to tackle your needs on climate service and based on Earth observation. So what are the main questions that we can ask to formulate these specifications in a functional manner? You want to find out what function the service or product or solution will fulfill. You can ask yourself, what problem do we want to solve? What is the cause of the problem? And use some techniques to get some insights into the solution of the problem. You see here the functional analysis system technique, that is a technique that is used to first define the scope and study of the scope of study of the problem, and ask some questions to gather in a logical manner the functionalities that you want to achieve, whether these are basic primary functionalities or second functionalities. You ask, how does the function tackle the problem? Why do we want to tackle the problem? But we will do this in practice during this workshop. So in this context, thinking about what we need to tackle, we have already some climate change problems and risks that we are facing and that are pressing at the moment. Specifically for the area of energy and utilities, for example, you have common risks of the interruption or disruption of the services. We see also that the EU taxonomy regulation is defining the economic activities that pursue environmental objectives and that contribute substantially to reducing substantially to reduce or preventing adverse impact in the future. And the way they contribute substantially to that is actually to prevent those risks, to prevent those adverse impacts. And that's why we want to have this action that is fulfilling this mission of objectives related to climate change. In the principle, we have formulated one common need during the high-level conference of Protect in Barcelona, and this common need was the illegal dumping of waste. So for those who were there in Barcelona, this problem was seen as a collective problem, for example, it was stated that if there are heavy floods and the waste is there and is carried out into the soil and the water, it can cause a lot of problems. And the question they asked themselves was, how can Earth observation help waste management? Well, it's possible perhaps to use Earth observation to contribute to detecting, monitoring, warning, alerting illegal dumping, and use these systems, this information in the systems in a way that public authorities can work together to provide a better service. So this is one example, but we would like to see what other common needs and interesting challenges you have. So here's a next question for you. You can go back to Mentimeter and let's see if the detection of illegal waste dumping is a relevant need for your organization. Let us know if this is a relevant need. So we go to the next question. Oh, sorry, we go a little bit earlier and go here. So we're waiting for the players. Yeah, we're ready. We go to the question. And let's see if the participants voted okay. So this is a relevant problem for some of you and not for others. So let's see what other problems can be challenging for you. But before we do that, now let's get a little bit of context regarding Earth observation. So what is Earth observation and how Earth observation can help us tackle these climate change problems? So I will give the floor to Ioana now for her to give us an introduction in this regard. I give you the floor, Ioana.
Good morning, everyone, and thank you for joining our workshop today. I'm Ioana. I'm going to introduce you a little bit in the Earth observation and the link between the Earth observation and climate services. So, according to the European Space Agency, Earth observation is defined as the process of acquiring observations of the Earth's surface and atmosphere via sensors mounted on satellites, aircrafts, drones, or at the surface, resulting in data in the form of digital imagery. For the last several decades, Earth observation has been an essential tool for monitoring the planet, the environment, the human activities on the planet, and also the impacts that we are having. For instance, Earth observation has been fundamental to monitoring climate change over the past few decades, as satellites provide a clear, uniform, and continuous picture of changes across the entire planet. The vast amount of data collected through Earth observation is processed and converted into actionable information for the end users across several industries. Two supporting technologies enable this intermediate step of processing Earth observation data, and these are artificial intelligence, known as AI, and cloud computing. When it comes to cloud computing, advancements over the past few years have enabled the efficient storage and processing of digital data, thereby facilitating the conversion of Earth observation data into useful analytics. When it comes to the artificial intelligence, which is the field of computer science dealing with making intelligent computer programs, has allowed a huge amount of data collected from satellites on a daily basis to be combined, effectively allowing the users to derive the needed insights. These two together, the convergence of AI and cloud computing, have enabled the rapid growth of the EO market, leading to the development of several applications of Earth observation. Next, please. So one of the one of the largest programs for Earth observation in the world is Copernicus program, which is managed by the European Commission. It has as an objective to monitor and forecast the state of the environment on land, sea, and in the atmosphere in order to support climate change mitigation and adaptation strategies, the efficient management of emergency situations, and the improvement of the security of every citizen. Served by the dedicated Copernicus Sentinel satellites, the data collected is then integrated with non-satellite sources to provide reliable and up-to-date information about six thematic areas: land, marine, atmosphere, climate change, emergency management, and security. Next, please. But what is the role of Earth observation in climate services? Well, as the climate crisis continues to evolve with the ongoing global warming, the governments and businesses around the world are focusing on climate adaptation and climate mitigation initiatives. In these actions, Earth observation data is expected to play a crucial role in the development of the climate services, both focusing on adaptation and mitigation. The satellites, which have been monitoring the Earth continuously and helping our understanding of climate change, provide vital information regarding the state and evolution of the environment, as well as regarding the human activities on the planet. As a result, the climate services applicable to several industries are expected to integrate Earth observation data into their products in order to take into account the environmental factors and changes over time. Several emerging climate services have already started to integrate Earth observation data into their development, from providing extreme weather alerts for better disaster preparedness to both governments and businesses, to delivering crop-level insights to farmers, enabling water savings and improving overall yields. There are a number of climate services currently available in the market across a number of industries. And now we are going to talk about a specific example. If we're going to the next slide. So the main question is, how can climate services apply to the 5 application domains? As you might already know, Protect project is focusing on 5 different application domains. And today we're going to talk about the one for energy and utilities. Thank you, Ana Lucia. So As a definition, the energy and utilities application domain includes all activities related to water supply, sewage services, electricity, dams, and natural gas. When it comes to their climate services, they rely on Earth observation data for forecasting and nowcasting, planning and optimization of renewable energy like onshore and offshore wind, solar, tidal, and wave, and monitoring of strategic for the utilities sector infrastructure like pipelines or dams. Thank you. Next. Okay, and now we have a specific example of usage from the category of environmental impact monitoring, which which can be called as environmental impact assessment of energy and minor resources plan. In this case, Earth observation can support the mitigation of the energy or the mining effects of the environment through continuous monitoring of relevant environmental characteristics and through the capacity of Earth observation to detect the changes. The relevant products and services include the coastal ecosystem monitoring, the water quality monitoring, air quality monitoring, erosion monitoring, the pollution or vegetation monitoring, and in some cases, Earth observation-based products could also include the production of environmental impact assessment certificate. And now I can pass the floor to my colleagues, Ana Lucia and my colleagues from Climate Geek to give you more.
Thank you very much. Thank you very much, Joanna, for the clear presentation. And indeed, now we could look at what climate services is Protect looking at. And I would like to give the floor to Tantam or Kevin. Very good. Thank you, Tantam.
Thank you, Ana Lucia. Thank you, Joanna. So I won't be long. That's a snapshot on the part of the taxonomy of climate services that Joanna just alluded to that is relevant to this domain of energy and utilities. So you can see there's a lot about energy, which is not a big surprise because obviously energy is one of the sectors most at stake, both from a mitigation and an adaptation perspective, by the way, because of course there are mitigation issues. So typically, power plant design optimization is both a mitigation thing because you want to avoid, faulty designs that would increase the risk of leaks, the risk of negative impact, but also it's a matter of adaptation because it's about extreme events and how you are sure that you are resistant to such events and even resilient if their strength is exceptional. So there's a lot about energy and all those categories on energy. What is important is the description to the right, category of climate services, where you can see the scope of those categories. Maybe before I come back to those categories, just a reminder for those who did not attend the introductory webinar for Protect. In fact, this taxonomy doesn't have the ambition to be the final taxonomy on climate services. One, because it would be huge work, but two, because it's not even clear that there should be one taxonomy that is universal. What we aimed at was a taxonomy that would be workable and that would be fit for purpose for what Ana Lucia has described. So what we want to achieve with you, with public procurers and market actors as part of Protect. So how was it made? It was, I won't get into the detail, but it was a result of crossing climate service taxonomies, some of which have been developed and proposed in the last few years, with Earth observation taxonomies, which Joanna has briefly alluded to, and also to those 5 specific Protect domains. So those domains, in a way, look, well, they're quite common sense. As Ana Lucia said, there are some of the areas where you have the biggest impact. But in fact, it's not completely, square how you can match the 3 perspectives, climate services, Earth observation, and application domains. And it's very important to do so because one of the big challenges of working in this space is that there are different languages being used by each of those 3 perspectives, and that means that there is quite a bit of loss in translation between what is available in the market, what could be available, and what are the real needs that should be addressed by climate services. So what you're seeing here, coming back to the table, is the list of the types of climate services in this domain. So you can see, if you have seen in passing excerpts from the taxonomy on other application domains, those ones, the subdomains are quite wide. They're quite generic in a way. But that is natural in a way because the people, the stakeholders who are dealing with the needs generally have quite a transversal responsibility over infrastructures in particular. So it's sometimes artificial to divide, into subdomains that would talk about the supply, that would talk about the leaks, that would talk about the infrastructures in independent ways. One of the big stakes is to have climate services that can speak to several of those levers. So anyway, you may see that this is helpful because it's a bit more detailed than the categories that we're used to in publicly available taxonomies. It is not too much detailed, as I said, because you don't want to break things into pieces where it's very interconnected. So why are you seeing this? Well, first, it's meant to help you, and in particular, the public procurers or the organizations who are working very closely with public procurers, to be able to better pinpoint your needs and express them in a language that is easier to understand by the other actors in the market. So where is the Earth observation / climate service market currently addressing needs, and you don't know that there are solutions that would be relevant to your demand, but also where it's currently not addressing your needs. So you may very well see on this table that there are gaps. You have identified some needs that you think could be addressed by climate services, and yet you don't see them here. So there is one obvious example, which I realize that there's nothing but dams, for instance. But even within the energy or waste of drinking water sectors, you might say, well, that's not exactly the way I perceive my needs. So you can have two situations, as I just said. You have the situation where the market actually has answers to you, but you don't know them. And there is a situation where the market doesn't have ready answers for you, and it has to be co-designed. So in the latter case, there may be a need for a pre-commercial procurement process because no solution is existing for the problem the way you perceive it. There may be, and there are probably a number of bricks that could be relevant, but in fact, they are not meant and organized to work together, and they don't seem to be matching the full extent of the problems you're facing. But even the former case where there are solutions in the market, it's still in many cases interesting for you to go for a PCP, because it's about developing different technical solutions than the ones which are already in the market, the way they are formatted into services. So in fact, a lot of the information you could get from PCP is not just what is already on shelf but you didn't know of, but it's very much what are the possibilities between, let's say, TRLs 3 to 7. Correct me, Anna-Lucia, if I get the number wrong. Even 3 to 8 sometimes. 3 to 8. So those solutions which are potentially ready in the next couple of years or even 3 years from now, but which need to be developed properly to really understand how your demand is appearing and how you're formulating it. So that's really the aim of this taxonomy. It's not the answer where you just have to choose your box and click and go open the box and find the solution. But it's really a way for both sides of the market, the demand, which you represent for some of you, and the supply, which some of you also represent, to have this dialogue before you get into a formal, call for solutions and the traditional procurement processes. Okay, so I think I've been long enough for now, but very happy to contribute to the rest of the discussion and move to your real needs.
Great, Tam. Thank you for the insightful presentation. And well, thinking about what you just say, it's important how the demand perceives their needs, what is actually what they require, the functionalities they require. And here we have some example of functional requirements in the energies and utilities, just with thinking about the potential of Earth observation, described as with an active verb and a measurable noun. So to see what is the function and also what can be measured. For example, monitoring the solar yield for grid optimization, detecting activities in energy corridors, analyzing historical data for water quantity and quality. So these are some of the things that could be functionalities that you would like. But passing now a little bit further into the second point, let's look into the EAFIP methodology, because we have said that we want to prepare a pre-commercial procurement, the grounds for a pre-commercial procurement. And in doing so, we are using the methodology that has been developed within the context of the European Assistance for Innovation Procurement. And this is a methodology for implementing innovation procurement, whether it's PCP, pre-commercial procurement, or public procurement of innovative solutions. So PCP at lower TRL levels from TRL 3 to 8, like Tantan mentioned, and PPI at higher TRL levels where the solutions are closer to the market. So here you see the different steps on innovation procurement project, starting from looking at what are the research latent needs, the needs assessment and prioritization, and we do that with sessions with end users, evaluating and prioritizing common needs. That's what we want to do today. When we have defined use cases and keywords, we proceed with a state-of-the-art analysis, understanding what the market can offer, but also looking at the overview of relevant patents, standards, and literature, and also mapping the potential suppliers. While after doing that, we want to validate these findings through an open market consultation. So we test the needs feasibility and the SOTA findings. We also test a preliminary business case, the assumptions that we have, the calculations that we have done, and we get insight from the market, feedback from the market. With this information, we fine-tune our business case. We do this cost-benefit analysis, also a value calculation. As I mentioned, we have different scenarios that we consider. And with all of this information, we can go already to design our procurement strategy and the tender document with the provisions, the clauses that we find that we need. So, for example, in order to do that, we need to know what the TRL level is, to know which trajectory we take, whether it is PCP or PPI. We also determine the intellectual property rights strategy. In PCP, it is a standard approach and a recommended approach to leave the IPR vested in the suppliers, in the contractors, so that they can exploit and further commercialize the solutions. And of course, we prepare the tender document in a sound way, taking into account, of course, throughout all the process, the main principles, which are transparency, equal treatment, non-discrimination, competition, proportionality. So in the procurement process steps, we are looking at the tender already. We receive the proposals, we evaluate the proposals, there's the award of the public contract, then we come to the contract management. We need to monitor milestones and deliverables. This is also done as contract management during phase 2 and 3 of the PCP, which have different competitive phases. So we do this monitoring. In some cases on PPI, we monitor the implementations of value engineering clauses. And the final steps are the evaluations and the lessons learned. We do these continuous evaluations vis-a-vis benchmarks, vis-a-vis the key performance indicators in order to have an improvement throughout the process. And finally, the post-contract management. Here we monitor even clauses that or contractual obligations that subsist after the termination of the contract. For example, royalties on IPRs, the monitoring of the commercialization of the solutions. That is in the case of the PCP, that we always include provisions so that contractors actually commercialize the solutions within a period of time. Also some standardization obligations that the contract has. And for Protect at the moment, we are focusing on the first 5 steps to prepare the grounds for the pre-commercial procurement and be able also to present a proposal on the Horizon call that I've mentioned before. So these 5 steps is what we call the EAFIP business case methodology. Here you see the steps, the needs identification and assessment, where we define the problems, the requirements in a functional matter. Then we do the prior art analysis based on the keywords of the use cases. We describe the SOTA, we map the contenders or the possible the owners of IPRs. Then we have an analysis of the standards landscape to know the degree of consensus that is with regard to the type of solutions that we want to acquire. And we, of course, challenge the findings on the open market consultation to do our value calculations and decide the trajectory and the procurement strategy. So at the moment, we are here at the needs identification to see what problems, what challenges you are facing at the moment, which are these common challenges, how we define them in functional terms. Okay, so here we are in the first step, needs assessment and prioritization. The question for you is, what challenges and problems do you face? Whether they are current, whether they are future challenges. We know that there are already pressing challenges because climate change is here, and we want to have this function-based specification. And for, of course, the expected outcome in this regard is the description of the problems, the needs as functional requirements. We would like to have ideally a use case at the end of the workshop, and this use case should relate to the climate services that use Earth observation. And finally, if possible, we will describe a value pilot, so in a scenario related to new or to be developed climate services based on Earth observation. So here is where we are, and we are going to use a few methodologies in order to do that. These have been already embedded in the questions and in the dynamic of this workshop. So these value methodologies are used to prioritize and fine-tune the needs that you have based on the climate changes that have been identified in the 5 application domains, and the outcome will set the basis to define keywords on the functions and the performance that you require with the purpose to conduct the state-of-the-art analysis, and indeed define and fine-tune the procurement challenges that will be addressed by a pre-commercial procurement. So the value methodologies that we have embedded in this workshop are 3 mainly, with the purpose to obtain functions, use cases, and value pilots. The first one is the function analysis system technique. That is methodology that describes the scope of the problem and asks the questions, what and why do you want to solve this problem? The value stream mapping and the value stream design, these are based on the Lean methodologies in order to identify the as-is situation, the wish situation, and the steps that we need to take in order to reach to that situation, understanding where lies the value in those steps. Okay, so this brings us to the third question, and I will give a little bit of time so that you take out your phone again, look at the QR code, and reply with 3 words. What are the most pressing climate challenges, problems that your organization is facing at the moment? So I'm going to try to do it also myself to give you some time to get the QR code. And yeah, you did it. So now I'm going to go through the Mentimeter. Next question. Yeah, there it is. And you need to enter a word. So you have some time to type. Okay, interesting, very nice. We have some keywords. I see that we have energy resources is one, drought, water supply, water quality, waste management, water demand, greenwashing. Okay, so we have water supply, water quality, water management. Who would like to give some input to explain the problem that your organization is facing? And I would like to give the word, let's see, go back to this one. Anybody would like to participate? I think perhaps I can give the word also to Olaf, because we have exchanged, he has pointed out some interesting problems via email, and I think it's worthy to give it a thought. And perhaps this is something that is common for other organizations and other users. If you agree, Olaf, I'll give you the word.
Yep, thank you. Well, to start with, my organization is not active in water itself, but for the water sector, and the water sector has a problem with climate change, obviously, longer and more periods of drought. That's problem one side, but also on the demand side, you see the counter effect is more demand for good quality of water. So that's not per se new, but what's new is that at least in Northwestern Europe, we're looking for more solutions to tackle this problem. And one of them might be looking in the sewage system itself that the water authorities treat wastewater to clean water again, of course, that's discharged in rivers or lakes. And what if we are able to connect supply and demand, supply of treated wastewater with the demand for fresh water, sweet water, so to say. And maybe Earth observation technology might help. They can predict demand for water for agriculture. I think that's not new. I think that's already existing. You can, with Earth observation, look at the moisture content in soils, for instance. Based on artificial intelligence, I guess you can predict also what will happen in the next days or weeks in cases of drought. But also the availability of the use of water by consumers with data from sewage systems. Well, you can make smart connections which are not, I think, available at this moment, or at least not connected. That was just what my idea, what I sent to you through the email.
Thank you. Yes, thank you. Thank you very much, Olaf. And I would like to share with you, because you sent some compelling articles, and I've seen that we also have participants from Italy that may relate to this. Let me see if I can go to the wait. I will just try to change to see. You can see my screen, right? You sent me these articles about the low rains and the shortage of. You can see the effects of the rising temperatures, and
rising temperatures, longer periods of drought, less snow in the Alps, for instance.
Yeah, exactly.
What I try to do with sending you these articles is showing that it's not just a local Dutch problem, but
Yes.
I think maybe for it's new. For Southern Europe, it's maybe also already.
Yeah, and you see these. You can see. Okay, so that you see the result.
But my main question is, however, I studied hydrology a long time ago. I did also some telemetry, so Earth observation lessons I took. So measuring drought, moisture content, I guess that's not new. So I don't know if any people are here that have this knowledge in if this is an interesting topic and to make connections between supply and demand.
Okay, so we understand correctly. Perhaps like predicting drought or identifying drought is not new, but what we want to do is connect the supply and demand. So those who are in need of water and those who are actually producing water that could be used for farming or for other uses, and knowing that this water has the quality and the conditions for the use that is needed.
Exactly. And then if you know, you can act on that, store more water in the system, for instance, or produce more. Well,
Perfect. I think Tantam wants to, he has his raised hand, and he perhaps can enlighten us, shed some light on us.
I'm not sure I can shed light, but I try not to shed more light. No, I think just as a compliment to what Olaf just said, I think and it would be really interesting to hear from Michele Bartolomei or Stefania Blanc about how they see this in the Po Valley or the Ebro Valley. I mean, two things. So one, in France, as you probably have heard, we're just right in the middle of this very, very big tension and clash about water management, water storage, and so on. So I mean, I'm not going to talk about that, but it's a prime example that all of the levers, which are of course physical availability, but also the economic levers, the societal levers, and also ideological levers. I mean, all those come very concretely at an interplay. And I'm not saying that climate services are going to solve that alone, of course not. But the fact that people are not discussing on the same data, responding to the same criteria of analysis, is a massive problem right now. I mean, and it's, when I say massive, there are human lives at stake. I mean, literally right now. So that's one. The second thing is on what you said, it's true that the prediction of drafts and including not just summer drafts, but this chain of consequences from winter drafts and so on is now we have pretty elaborated models and mechanisms. But again, actually, as you said, people are looking for solutions, and what we see is that the solutions and the way they are going to be appropriated will change the parameters of the equation. So in fact, the modeling is incomplete as long as you don't know how people who will be actioning the chain and how. So I'm saying things that are completely obvious to you, but I think it's probably important to share that across the types of stakeholders, because it's rarely considered from let's say common challenge perspective. It's more an arbitration thing. So that, yeah, that's the two things I wanted to say. And also even in physical terms, and I'm not a specialist, I mean, of that, but I've been discussing quite a lot with scientists in the southwest of France. And in fact, they said that, yeah, they have tons of data on the different factors that would contribute. As you know, the southwest of France has mountains and a sea and anything in between and rivers. So they have, in a way, a complete ecosystem on that. But even with that, they said, even with the data they have available, to put them together and bring them into an analysis of the chain of constraints that goes beyond the micro-local scale, it's actually still a scientific challenge. Sorry. So it's not, maybe all the data are there, but in fact, the way you put them together is absolutely not obvious even to this day. And the very final thing is building on the article you showed. I think it's we are completing rough analysis of the main climate risks at regional level across Europe. So not every country, but a number of regions. And it's actually quite interesting. You see draft everywhere, but it's true that the seasonal aspect of draft and the weight of winter drafts, summer drafts also is extended or moving interface between the two. And also in some cases, the specific spring drafts, in fact, that's surfacing in very different ways across the regions. So I think one of the things we may want to do, and I'm sure you have done that in your from your perspective, is to try to connect regions across Europe who share more or less the same seasonal stress, in fact. And some of them are quite distant geographically, which is quite interesting in terms of what you can do with climate services. Okay, so that's the only thing I wanted to add, but
Yeah,
if you or Michele or Estefania have things to add, it would really be very welcome.
Oh, yes, please feel free to participate, Stefania, or yeah, please go ahead. It would be very nice to listen your insights in this regard. One thing I would like to mention from the nice explanation that Tamtam gave to us is that perhaps modeling is one way of doing that, perhaps identifying the type of data and having a common language in order to modeling and connect these needs across the Europe. Is that one thing that we could do perhaps, or the way we could start something? Don't know what your opinion is on that, whether that's possible for others to participate or not? Or Tamtam?
It might be interesting indeed to find a region with or maybe general problems that other regions also face, and try to connect the different parts of the water cycle. I think there's a part of the there's a lot of data on drinking water, wastewater, surface water, rivers, which is surface water but moving water, snow, glacier volumes, and to connect those gives a much better projection in time on an hourly basis, weekly basis, annual basis, maybe decades, giving us data for solutions on the short term and long term. And you can do the same for demand side, agriculture, type of vegetation, forest. I guess you can also have a lot of data on that, predicting how much water is used there. And that, if you do that for a region and model it for this region, and it works, then maybe it can be extrapolated or used in other regions. I look at it from a bigger perspective,
Yes.
which is not my sector in total, but I think finding solutions for this big topic of water, we need to look at it from a wider perspective, not just
Yeah,
from
yeah.
drinking water, not just from
Okay.
agriculture. But you're right. I'm reacting to your suggestion. If you
Mhm.
have to start in one region, try to model it, see what kind of data is available, and try to connect it from there.
Yeah, great. Yeah, that's Stefan. Yes.
Yes, thank you. If you speak about a wider perspective, it sounds to me that we're still in a sort of understanding from a policy perspective what the consequences are. And of course, we have contracting authorities, public authorities working in this this sector, like the water companies or the water sanitation companies, but also of course, agricultural organizations that are responsible for this, industry, etc. But if you would like to combine that to understand what the issue is, then we're looking more at it from a policy perspective. So are you saying that we're lacking the data, lacking the info in order to develop proper policies? Is that what you're saying? Because if that could be, yeah, but then then our target audience should be more the ministries, you know what I mean? The policymakers, and not the organizations that are relevant for the execution or the implementation.
Yeah, good question. Yeah, maybe it's both. I don't think we're lacking data, but we're not connecting them.
But that's a policy issue, eh?
Or the
I mean
language
that
is different,
if
like
we are a
1000.
contracting authority, to give you an example, if you're a water company, so I have a public task to ensure safe drinking water in the right qualities, etc., and when there's demand for it. So this is normal task that we have.
Mhm.
But if you see a threat on that from the climate change, of course, then we say that the demand is higher than we can supply, or the supply has poor quality, or whatever it is. But that signal should be sent to the policymakers in order to understand, okay, how should we react to it from different sectors, from different perspectives, putting everything into an umbrella approach, huh? So you know what I mean. So I think that what you're saying is, I think that's very important, is that due to climate change, we see in the operations all kind of issues arise. But what we are lacking, apparently, is the fact that the policymakers needs to follow that up. Is that what you're saying?
Yes, yes, I am. Let me also give you why I came to this suggestion. I visited a water authority in the far end of the Delta in saline circumstances. And during the last droughts, they had a big problem with farmers asking them for treated sewage water. And they had no understanding on how much was needed by the agricultural sector, when they needed it, what quality they needed. Although they saw that they had sweet water, discharging it in saline water bodies. So it was a waste of sweet water, so to say. So if they had the data, also from a short perspective, maybe on an hourly basis, but also looking into the future, what are the coming next year, so they could invest in storage, for instance, or so that's how I came to this perspective and try to see it from a wider perspective, and found these articles about the Po Delta, where I think more or less the same problem and solution is we never connected treated sewage water with water demand, at least as far as I know.
Yeah. And Tam, may I ask you, because you're the expert on policies and things like that, I assume that from European perspective, you're already working on this. Can you say something about that? So perhaps we should also try to connect to the European Commission on this.
Yes, so I don't know how I have led you to think that I was a policy expert, but thank you for the question. So I think maybe in fact there are two levels. So I think at the level of the European Commission, one of the points where we would have the easiest access is through the mission adaptation, I think. So I know it's not just an adaptation thing, but I can see, for instance, in some of the projects we're involved in or we're going to start, there are several which are around exactly this, lack of appropriation of data by public decision at a local level or regional level, as you mentioned. And in fact, there is an appreciation. That was the other point I wanted to make, but it's really connected, which is that. There are really two things required. There's the one that you just mentioned, Stefan, which is that let's say public decision has to own those questions. They had to appreciate that they will have ultimately not the only driver, but they will have the let's say determining a decisive impulse in addressing those issues. But the other thing is that they are struggling with that. So if I take again the example I took before. Right, what the scientists who have spent a lot of time discussing with local authorities said was that, in fact, they were ready to take and they were willing to take their responsibility on public decision, but they just felt they didn't have the insight over the range of data and the competence to arbitrate, and even to conduct arbitration dialogue in their local communities around that. So it may not be, I mean, of course it's complex, but it may not be that complex, but there is now an explicit move from the Commission and the mission adaptation to address this issue in particular, which is really how do you not just provide, the data and the tools, but you actually support actively the, local authorities to use those tools to say how they cannot use them and, complete them as needed. So I think that's probably the first avenue, but then I think the second one is indeed if we can clarify, as Protect, but Protect is not just a consortium; it's very much the other actors, the procurers. If we can clarify how exactly you would want, the PCP call in a year and a half from now, or almost 2 years from now, to support. The real gaps. So I think what Olaf has been describing, that's really helpful. I think it's very important that that people who are in charge of typically a water basin where you have this lack of connection between wastewater and drinking water, for instance, that they really step forward and tell us what is actually among the issues we can imagine, what are actually the ones where they feel helpless because they don't feel they have access to the right tools, or they don't see that the tools that are available are actually allowing them to take this responsibility of arbitration.
Yes,
so I think it's a long issue. Yeah.
But the first starts, of course, with understanding what's happening. So understanding what is happening and doing the monitoring and inventarizing the effects through satellite services as a starting point. We should also understand that if the satellite services that are currently available can already addressing this, and if not, then of course there's a need for new services, or of course, and I think that's also important what Olaf was mentioning, to understand how these the satellite data can be enriched and can be sent as sort of new ways to make decisions on, or something like that. So you have decision-based systems needed in order to, and then of course, then the interesting part is who's going to be the customers. Are then that the policymakers, or are that in this case the water companies or water sanitation companies? So I'm trying to find the relation between the picture that you just draw, Olaf, and how we can make that feasible for the PCP, and how we can relay that. And perhaps then Joanna from Aerospace Valley, do you have any idea on this? For example, what kind of satellite services we have in this respect, or not yet?
I actually had connection problems and I didn't hear everything. I'm sorry.
Okay, so we come back to you then with that question, Joanna, to see if you know if there are already existing satellite services that can tackle this or not, because we have no idea, and that's what we need to find out. But
the data on the cycle of water.
Well, yes, but also because the issue that was mentioned, starting with to understand the relation between the supply and demand. and how to connect. And I think that's really important. The other point that Olaf was mentioning, the fact that you do not want to use valuable drinking water for, I don't know, for agricultural means or something like that, because that's really a waste of good water, because you could all have other water quality that's needed for for agricultural purposes. So all of that's correct, because that's what that was what you talking about.
Yeah, and there's so many that makes it very complex, of course. But agriculture in brackish surroundings are in strong need of sweet water, and indeed, in times of drought, they are looking for any water they can find. And if the use of drinking water would be a horrendous waste of really good water, indeed. While treated sewage water can do the trick. There are some challenges there as well, but yeah. And
I don't know if our Italian, if our Italian participants have some feedback on this from their understanding what's happening in their region.
Stefan, I think Joanna also wanted to reply to.
Okay, I didn't hear that. Sorry.
No worries. I just wanted to say, as far as I know, there are technologies that are working on switching the salty water into sweet water by removing the salt from the water, but I don't know how this can be linked to the Earth observation. So if you want, I can try to take a look at it, and I can come back to you with an answer if this can be connected with Earth observation and how they can work together.
I don't think the problem is transferring salt water into sweet water, because the challenge is that the drought is like for 2-3 months, and then you have an installation for the whole year that treats salt water into sweet water. It can be a solution, but from an economic perspective, I don't think that's it's maybe better to look first at other sweet water sources. It's solutions for some. I know, for instance, in the Spanish costas, it's a quite common way of treatment. But there's a continuous shortage of sweet water. What I was thinking of is more the variation in time with large availability and shortage of sweet water. But I want to steer to a certain solution. But it's the perspective that and that's what we discussed before. What specific region has a more general challenge that's comparable for more regions in Europe to start with?
Well, we have some examples in France now, Tam, on the drought for certain periods.
Yeah, no, indeed. So in fact, so in France, for instance, you have two kinds of situation. Well, you have more, but you have at least two kinds of situations. So there is one which is typically in the south, where you have had this drought problem for quite some time. And as you just said, Olaf, it's not just about only desalination. I mean, desalination, of course, is part of the equation. It has to be. But I mean, an example I had in mind is the which I mentioned yesterday in another webinar, was the vine sector and vineyards. And in fact, it's and that was also a question for you, Olaf, but also for our other participants. I know for the vine, for instance, one of the big issues is what is this perceived threshold of tolerance and water quality that is acceptable. And in fact, it's actually, I was surprised to see that even people who are working on this topic are not necessarily aware of the experimentations that have been done, for instance, in Southern Australia, where they have been using wastewater for many years for very good quality wine. Well, maybe you don't like Australian wine, but it's still supposed to be quite good wine. And this has not caused concerns for public health. And so the question is, in fact, in the regions, well, where you are, but also in the south of France, typically, how can you use what is already has already been tested, and how can you bring this confronted to the perception that the general public has of how safe it is to to use water that is not drinking water. And so that was a question for you in your experience, for instance, you know, is that an issue, or are people quite open? I'm sure farmers are, I mean, but consumers, are they open, you know, to that? The other thing is the second category, I think, is on the, sorry, just switch off this phone. The second category is on the regions which were not historically affected by massive droughts. And more of them are, and it's especially in the hinterland where you don't have the water to desalinate. So it's typically in France. If you know France, that's happening in Limousin. That's happening in you know, in areas which were really supposed to be quite rainy and so on. So now the reserves are really very, very thin, and sometimes they are completely empty. So so now they have to look at those solutions to store water. And what you get there is typically the problem we're having now with the reserves. Well, there's one which is the interventions and the right of use and the priorities. But another one is, in fact, the fact that even when you store those reserves and you don't want to have them too closed, you know, so you want them to be reasonably connected with the natural ecosystem, then how long does it stay at a level of water quality that is acceptable? So if you store it for several months, as you said, it's a seasonal thing. Is there a risk? Do we know, in fact, what is the risk of contamination between the time where you store it and the time that you use it, and all this? So again, I don't want to be too long. It would really be interesting, but I don't want to force anybody to speak. But to know how it's happening in the Po region and in the Ebro region. I know in Valencia, for instance, it's been a topic for centuries. Literally, they still have this water court, you know, which is gathering every week. That is really not just about how do you desalinate water. I mean, it's obviously how knowing what water is it. How do you know what water is available? How do you know what wastewater is produced by whom and what is contaminated with? And how do you agree collectively on what is deemed acceptable as a general balance of the water distribution? So it's not magic, but I think that in many areas we're talking about, this basic dialogue is not happening. And if it's not happening, then there's an untapped potential to reuse water, as you said, Olaf, that is simply not analyzed because there is no dialogue sharing those data.
Okay, thank you so much, Tantan. I see Michele posted something on the chat. He's not the right person to talk about water, but I don't know if Dani or Stefania can give their input. But in the meantime, you could look at question 4 precisely to write how can EU data and services support the tasks of the organization to contribute to climate change mitigation and adaptation. You can just please go back to the Mentimeter. We will go back to these questions, and the players are joining. So we refresh this one. So we can go. Okay, the player is ready. To reload it, you can reload it. And yeah, we have some players. Since you have to type on this one, you give a little bit of time to reply. Oh yes, of course, Michele, bring any other issues that you like to put on the table in this workshop, not necessarily on water, but of course it's open to other possibilities. So let's see, we can type. To give some time. Yeah, we have 22 seconds. There's no right or wrong answer. You just please type as you wish. And it's coming. Let's see, we have some answers. I think we have one. Okay, well, just type what we were talking about. So this is one of, let's say, the needs that has been formulated during the workshop. Okay, so okay, let's move to this one. So with all the information we gathered today, let's try to describe a use case. So here I will ask again to the participants that, provide their insights on the need. And in this case, Olaf brought this example. I would kindly ask you to, just again, try to describe the situation as it is now. If you could describe it in a short way, how could you describe the situation now? Now there is not such information, there is not such data, it's not possible to connect supply and demand. How would you describe the present situation?
I'm not really into those companies, so I don't know what they know. But the most sure thing is indeed that the demand for sweet water is rather unpredictable. Has unpredictable variations, especially due to drought. Not connected with that. And on the other hand, what's not known by the demand side is how much is available from other sources than just the tap or surface water.
Okay.
Is that?
Yeah, that's a good way to put it. So that you say that the demand for sweet water is rather unpredictable due to the variations of climate, for example, due to drought, and there's also not possible to know how much you will demand and when, and what is there available from the supply side.
Yeah, from industry, for instance, from sewage. I would
from industry, from sewage. Yeah. Okay.
But if I may.
Yes, sure, Stefan.
Olaf, but the situation by law is that drinking water companies can deliver the drinking water to, of course, the households, or to, for example, for sprinklers and for industry, like to make beer or something like that. So that's how normally drinking water is being used. And what you're saying is that there's now another demand outside the normal sectors. Is that what you say? For example, for industry, not using it or agricultural farms also would like to have this kind of drinking water. Is that what you say?
Or sewage water, treated sewage water.
No, wait, because now sewage water is something different. That's something different. I'm really talking about the drinking water now.
Drinking water, okay, no problem.
The agriculture is very limited using drinking water. Mostly they use water from channels and so on.
Okay.
But they are it's prohibited sometimes, at least in the Netherlands in the summer due to droughts. But water demand during droughts is more in general increases. So sprinkling at houses, filling your swimming pool, but also for dust control in the industry. They sprinkle the roads and so on to prevent dust. So droughts cause an acceleration of use of water in multiple sectors, which becomes more and more because of the droughts, and becomes more unpredictable because it adds on. Because if they are not allowed to use water from channels anymore, they need to look for other sources. And knowing it where it is, when, makes it also from a policy perspective, so you wish, interesting to look, okay, but where can we find solutions in those areas for other sources of sweet water? What we see now in the Netherlands is becoming also more and more an economic factor, is that companies are not allowed to be connected to the drinking water system. We're out of drinking water. So from our Ministry of Economic Affairs, I would say finding solutions for this problem is a priority. You are right about looking at different sectors, but you can't see them apart from each other, because if there's a shortage, people look for alternatives. And in the north of the province of Limburg, for instance, they used drinking water last summer, which was very expensive for the farmers, but they had no alternative.
Interesting. Okay, but
Is it an answer to your question? I see you think.
yes,
No, because I think that so what we see is that the production of drinking water is not a stable amount, a stable volume. Because in period of droughts, we have to taking of drinking water from rivers or stuff like that. Of course, that's less than normal. Then we have to go to to groundwater, in order to have the production of to ensure the production of drinking water in sustainable volumes. So I think that drought has two effects: one on the supply side, and one on, of course, on the demand side.
Yeah.
So that means that if you're looking at the cycle of water, with drought, it has the effect of taking in, and producing, sufficient qualities of drinking water as a starting point. Because if the rivers have no water in the rivers, stuff like that, you have to go alternative. You have to look at the groundwater, for sure.
Yeah.
So there's an effect on the supply side, and then you have an effect on the demand side. So that is making it worse. But I'm trying to understand. Okay. So that's to drought. That is the consequence. That's what I can understand.
Yeah, but maybe one addition, Stefan. Please don't miss out on that. Industry, agriculture normally does not use drinking water. They have other sources.
No. Yeah, but that's the demand side. Huh? So, but what I mean is that so it has an effect on the supply side and on the demand side.
Yeah. Okay.
And the demand side is due to shortage. Then, not normal users are want to use drinking water as an alternative to from the channels, for example, what you just explained. So that is increasing the issue. But now I would like to understand, okay, so what is now the current situation? So the current situation is that, how do we deal with that on a day-to-day basis? Isn't it? That's what you're saying.
Yeah.
From supply and demand. And if you could think, if you have a magic wand and you could think of the desired dream future situation, how would you express that situation? How would you formulate it? Let's not look at any barriers now, but just look at how it would be optimally, ideally, the best situation, so that both demand and supply side would know exactly when they can, let's say, obtain the water that they need for the crops, for the industry, for any other different uses.
I think that's actually what the ideal future situation is. That two things: that we have a system that is coping with these stress situations, that can cope with these stress situations, so to say. So based on data, that we build a system which is resilient on one side, or at least to a certain extent. And the second part is that once the situation occurs, that we database driven solve the solution, distribute the water. So that's quite, and this involves a lot of data, more than we can here imagine altogether, but that would be the ideal situation. So understand that's the water authority, what I just mentioned, where my idea started with, is that they don't know how to, their current, their world is treating water. That's what they do. They treat polluted sewage water and discharge clean water into surface water. That's what they do. Now they have somebody knocking on their door, farmers saying, hey, in case of drought, can we collect water at your place? And that's a whole different, but then the question is when, where, what quality, as Tantan just described, things that start to happen. So, but back to, building a resilient system is, I think, ideal situation, having a resilient system. And in cases of droughts, how does the system work altogether? How do we do the driven, where remote sensing, Earth observation, can and will play an important part, because that's the nature that causes the droughts. So we can.
But what you're also saying is that at this moment we have two alternative chains of production. So we have the production of drinking water, so that we have the chain of customers, usual suspects, and then we have, I call it the water from sewage plant that are not connected as such. So what you cannot have in that would be the ideal situation, is that you could swap from one channel, how do you say that, from one supply chain to another supply chain in order to provide that water that is needed for the usage for industry or drinking water, whatever it is. So I think what is needed is to understand, because that would be the ideal, the dream situation, is that you could swap from one value chain to the other value chain or something like that. How do you know what I mean? In order automatically.
Yeah, there's a third source, of course, that's surface water that's used by farmers, but and also there Earth observation can help, because they can see maybe the quality of the water, the saline concentration, for instance, or algae or whatever. The volume in the rivers and the lakes can be predicted. So that's a third source. And yes, you're right. So it's not like drawing another line and then problem solved. No, there needs to be happening more. It's about quality, about legislation. It's about technology solutions on this storage. So it's this is not.
But it's good to dream on it. So now that we have the as-is situation and the desired future dream situation, let's look at the steps towards that. At least what can we start doing to get there? So what could be step one to do that? The first thing that we need to do. I don't know, perhaps know what data we need and see whether this data is available. What would you say?
I think Stefan mentioned that altogether it's a policy thing. Who's the puppeteer? Huh? Who's connecting all these
who are the users, and who is at the end taking the decision at the higher level somehow?
Well, exactly. You need to have a mechanism in place that's saying, so the ideal situation, desired dream situation, is that you swap automatically from supply chain to supply chain. You mentioned the three supply chain: drinking water, sewage water, and then the water from the channels and things like that. So ideal situation would be, I have a demand, and then automatically someone makes it happen that in a certain period of time you go to value chain A, and then to B, and then to C, whatever it is, or make a combination thereof, whatever it is. That would be an ideal situation.
But now let's see at the steps to get
and then
there.
If I have to go back, then we need to understand who are the responsible public authorities and contracting authorities and private organizations who are dealing with that. So inventorizing the relevant chains. And I think that's quite simple, because we know that.
Perfect. Then what would be the second step? So we are inventorizing the.
Then we need to understand, we need to do a gap analysis in order to understand where the gaps are between this, in order to come to the dream situation. And that can be on governance level, or it can be on whatever it is. But it can also be on that we're lacking certain data.
A data level,
A data level, and then of course because we're trying to find a way how to reconnect this to the Earth observation services.
Yeah, exactly.
So I think that if we come to analysis that there is clear need for other new Earth observation data or data sets, that needs to be part of I would say a system to analyze everything. I think that will be vital in order to understand if that's possible, yes or not.
Okay, perfect. So we have to inventorize first, then we do the gap analysis on the type of data, whether there's new data needed from Earth observation. And what would be the next step, step 3?
Well, developing a system in order to combine these data sets and to do a proper analysis and come to I say that, an automation, and perhaps with artificial intelligence to understand how to make the right decision. So decision-based modeling, something like that. That's what I think.
Okay, so decision-based modeling would be step 3, and step 4?
Well, then of course that was step 4. Then if you have you can take the actions.
Piloting maybe what you suggested before in the region. Piloting, see if it works. Yeah.
Okay, very good.
Maybe one of the challenges I think also in the earlier stage, just as a we are worried when there's a drought, then everybody is panicking and so on. Now in the Netherlands at least it's raining. Nobody worries at this moment. We are humans. I think also in one of the earlier phases we need to all the stakeholders get the real challenge for the future between their ears. See that they really are involved. Some actors in the whole water system do not have that big of a problem at this moment, but play a role in the solution, maybe. So maybe also the stakeholder engagement, is that the right term? Is also maybe something. If we have in the Netherlands, for instance, 5 wet seasons, wet summers, I think this challenge will slowly disappear from our. Just as a suggestion in one of the, I don't know if it's step 1 or 2, but at the beginning, I think.
In the beginning. Great. Thank you so much. Very good. So we have reached some results as a result of this workshop. Before I go to this, I would like to be open for any suggestions, any comments, any remarks that other participants would like to have, or questions that you would like to raise. Anything, please go ahead. Please interrupt me. Is fine. So here we have already found a problem, a real problem. There was the supply and demand of water, how we connect both those with real data, with Earth observation data. We have described the use case. This is a use case that, which are the users? There are different stakeholders that we have mentioned here. And one of the steps is to actually inventorize. I mean, who could be part of, who are the users in this case, whether these are the drinking companies, but also the farmers, but also could be at the political level who are going to take the decisions in this. Who do you think would be the main users, if you could point out at some of them at the moment? In this case. Would you like to mention some, or those that we have mentioned here, that as the water companies and what kind of authorities or public authorities do you think are the main ones within these stakeholders? Want to mention that, Stefan or Ola?
And in this case, I think farmers are important stakeholders. They are user of fresh water. Maybe the industry in dry periods of time as a user, but maybe also as a supplier, depending on where they are in the value chain. And I think that's where my perspective came from, is from water authorities. So sewage plants, which have now maybe become a supplier of a resource, water. Again, it sounds stupid, which is new to them, because they treat water and just discharge clean water in the water bodies. And now in dry periods of time, they can be a very important part of the solution and supplier of water. I think, but we need, I think, to go to depth to look for stakeholders, but I think these are the most important ones.
Great.
And not to forget the ministry, of course, from policy perspective.
Okay, perfect. Just to verify that, to validate that, then indeed we already thought about value about pilots. So if we could think, how could we pilot, let's say, a solution? How could we do that? What would we need to find? Perhaps if we connect these stakeholders, let's say, find farmers that are have problems with drought, and the water companies, company. Yeah, where do we set the pilot if you want to, and how would be the value that we get from this pilot? What would be valuable to get out of the pilot? If you could pilot, let's say, solutions, let's think that we have a solution already that we could kind of use or apply, or just to see how in the first phase can be implemented.
Tom, I have a question on that because I think from the Netherlands we have, perhaps in the eastern of the Netherlands, we have a good example there now with the Drenthe and things like that. So we have, perhaps we can do that. But I'm also looking outside the Netherlands. Is Normandy also one of the regions that has now these kind of issues? Do you know that, by example?
I mean, all regions have this kind of issues in France have this kind of issues to a degree or not. What I was thinking of, and we can dig into that, I mean, is that the nature of the challenges is probably variable. So for instance, in the Netherlands, from what I understand, and speaking in front of two Dutch people, there are some things on which you are probably more advanced. One is that there seems to be more consensus on the fact that this issue has to be tackled primarily in terms of the draft, and maybe less social resistance, but I'm saying that maybe the recent elections said the opposite, so maybe I'm wrong. The other thing is that you have structures across the country like water boards, etc., which do not necessarily exist in other regions. So what I mean by that is that in France, of course, we could find regions where the issue of draft and seasonal draft is sharper, but maybe we should choose a region where they have the same barriers, or more or less the same barriers that you have. Because if we take, let's say, one of the regions where we have a fight right now, the main barriers seem to be societal and in terms of acceptability, and so it's not. Of course, they're relevant, but it might not be the same priority issues you have in what you're describing, Olaf. So just wanting to make sure. And so another way to say it is that if you can help us formulate what are the biggest, let's say, the hardest barriers. So the ones that can't be addressed by local actors with what they have, it will help us twin with potentially other regions which have more or less the same kind of barriers. And Normandy might be one. I must admit I'm not into this detail, but it should be rather easy to find out.
Okay, so perhaps we could choose regions that have similar barriers, like you say, Tam Tam, and to see how we can pilot something with them.
Yes.
Okay, thank you so much for all of these relevant, important information. And we're reaching the end, or we have 1 minute. So let's see what the next steps are. So the next step after this workshop is to start selecting procurement challenges. Actually, vote and score to prioritize challenge. So you will receive further information on the work that has been done throughout the different working groups, and we will see what kind of challenges are common to the different stakeholders, the different participants, the different public buyers, and we will define the final use cases and keywords in order to perform the state-of-the-art analysis to identify where lies the room for R&D. What is that we're going to pursue throughout pre-commercial procurement. And with this, we finished on time, sharp 11:30. I thank you very much for your participation, for your ideas, your insights. And if you have questions, you have remarks, please do not hesitate to contact me. This is my email address. You have received the link through my email address, so you have it. And have a great day, and we will keep in touch. We will update you on the results. So thank you so much, and until the next time. Bye-bye.
Thank you. Bye.
Thank you.